What's up, people? Hey, hope you're doing great. We're going to get into 8-1. Welcome to Chapter 8. Congratulations, we made it out of Chapter 7. Exponential stuff. Boy, that was miserable, wasn't it? Bad news. Chapter 8 is quadratics. They're even more miserable than exponential stuff. So we got that going for us. Tons of new words, right? Some of them are, some of them aren't. I know we talked a little bit about these words at the beginning of Chapter 7. So polynomial, guys, this is just an expression with multiple terms in it. We have special names for certain polynomials, right? If you have two terms, you get to be a binomial, right? Binomial, two terms. Guys, it would look something like this. X squared minus 4, okay? Trinomials, as the name insists, would have three terms. Maybe it looks like this, 5y cubed plus 4y plus 10. That would be a trinomial. Degrees, right? I don't know why they put degree of a monomial, degree of a poly. It's really the same thing. Guys, we're looking for the highest power, okay, of the binomial, trinomial, polynomial, whatever it is, okay? So like if we look back at my trinomial here, the highest power is right here. So this would be a third degree trinomial, okay? This one here would be a second degree binomial, okay? Monomial, of course, guys, is just one term. So I'll write you a monomial here. XY. Curiously enough, XY, if I said, hey, what's the degree of that? That's actually a second degree, right? Because these two are held together. They both have exponents of 1. You add those together, like magic, you get 2. Standard form shouldn't be a surprise to us, guys. Just like we've seen standard form before, we will write polynomials in standard form. That means highest exponent gets to go first. In that highest exponent, the leading coefficient is sometimes the cool person in the group. Kind of like me. Miss Maley, not the cool person in the group. She would never be a leading coefficient, but I certainly would be. If you haven't figured out, guys, Miss Maley's in here hanging out. She's off camera right now.
Hi, guys.
Doing some work. Okay, so we got easy stuff up first here. We have to determine whether each expression is indeed a polynomial, so we'll wonder what they look like. If so, we have to find the degree, okay, that's a little thing we just talked about, and determine whether it has a special name like monomial, binomial, trinomial, okay? So first things first, I look here. Yes, indeed, this one is a polynomial, right, guys? Just like we saw with exponential stuff, we don't want to see division. We're okay with any other operations. So we can have the product of some stuff going on here. We can have sums or differences, that's fine, okay, but we can't have any division. So determine whether this is a polynomial. Yes, this is, right? I'll just write yes. Okay. Find the degree of it. Well, 6x, x is to the first power, so this is a degree of 1. And it has two terms, so its fancy name would be a binomial. Binomial. Bingo. Okay? Awesome. Letter B, or number B, as I like to say. Yes. Again, we see addition, subtraction here with our terms, so we're fine. This one, highest degree. So the first term, x squared, is a degree 2, as is the middle term, 2xy, right? That's also a degree 2. We don't add those together, but we just say, hey, this is a, you can say second degree. That's cool. Okay? 3 terms means, yes, you guessed it, it is a trinomial. Trinomial. Lots of writing here. This is annoying. Letter C. Again, good-looking polynomial here, right? Not really, right? Can't have, we could have a 5 here. That would be okay. But what we can't have is d to the 4th power, right? Because really that's d to the negative power and what, yeah, you can't do it. So no, you are a loser. Letter C. You do not get to be a cool polynomial.
You sound too much like Sal.
Number D down here, 26b to the 2nd power. What do you guys think of this? So this is just a product of some stuff we got going on here. So yes, of course, this is a polynomial. Okay, it is a degree 2, and its special name, of course, is a monomial. Okay, what if we had this, my friends? Let me make some room here. I'm just going to write in an extra one here. So we'll say 4x cubed plus 10y squared, I don't know, I keep writing addition, plus 7z, see you, Maley.
Toodles.
Okay, so what if we had this right here? So let's go through this really quickly. Is this a polynomial? Absolutely, right? Highest degree. Well, it's a third degree polynomial. Do we have a special name for this? Not really, okay? We don't. So we just say polynomial with 4 terms, right? Or if we had another term on the end here, be a polynomial with 5 terms, okay? So that's all that is. 1, 2, and 3 get fancy names. After that, you just get to be a polynomial, and that's all you are. Okay, state whether that is a polynomial. If it is, identify it as a monomial, binomial. This seems easy enough. So is this a polynomial? Absolutely. Trinomial. Degree of 2, by the way. Leading coefficient of 3. Haven't got there yet, but we might as well talk about it. State whether this is polynomial. Yeah, just 2 terms, right? Polynomial there. Good? No. Think about it. If I write this with positive powers, where is b to the negative 2nd power going? That's right. Somebody out there said it, right? This will turn into that right there. Can't do that. So you are a loser. You are not a polynomial, letter B. Letter C looks great. That's a good-looking binomial there to the 1st degree. And letter D, yes, good-looking monomial there. Okay? So that shouldn't be anything challenging, I don't think. Standard form. So people, standard form just says highest power gets to be written first. So find the highest, well, I take that back, highest degree, okay, term. This is a 2nd degree term. This is a 6th degree term. This is a 1st degree term, right? We would like to put those in numerical order from highest 6 to lowest 1. Okay, just got to be mindful of your operations here that say, hey, this is a positive or a negative number, okay? So 3x to the 6th power plus 9x squared minus 4x. 4x still stays at the end. Sorry, dude. Standard form. Leading coefficient is just the coefficient of the very first term, 3. Okay? Same thing here. If you need to figure out, hey, who goes first, this is a 1st degree, 2nd degree term, 3rd degree term. Okay? So 3rd degree term is going to get to go first. So that's 8xy squared. Then we're going to have 6xy, then 5y, then 12. Okay? There it is. Leading coefficient of this one, 8. You got it. Okay, last one here. Let me make a little bit of room. Great. Okay, degree of 1. This is a degree of 0, right? If you're just a constant term, your degree is just 0. Degree 2, degree 4, degree 3. Okay? So 8mn cubed gets to be first. Okay? Then we're going to go with, yeah, of course we got that. Oh, that's a, sorry, folks, that's a 72. Eyes not working very well today. Plus 5m plus 21. Goodness gracious. 1, 2, 3, 4, 5. 1, 2, 3, 4. Yep. Okay, we got them all. Good. Always good to double check your work. Leading coefficient 8. Okay. Nope. Now we can move on. Okay. Again, nothing really too challenging today, right? It's kind of nice. We ease into chapter 8 here. So we're going to do some adding and subtracting of polynomials here. There really is nothing tricky other than you have to remember when we're combining polynomials, right, or terms of each one of these polynomials, x's only combine with other x's. Okay? Y squareds will only combine with y squareds, not otherwise. Okay? Xy will only combine with another xy. So you have to be like terms, same variable, same power. Okay? I'll show you 2 different methods. Don't care which one you do. Just whichever one you like better, do it. Okay? Horizontal method says literally just keep them the way they are. I do not like this color. Let's do this one. Great. All right. So 7y squared plus 2y minus 3, right? And we are adding this expression to it. I don't need to change any of these signs in here, right? So this is just, hey, you're going to add 2 minus 4y plus 5y squared, okay? One of my favorite math teachers a long time ago, right? They were big on lines and geometric shapes to figure out like terms. And I don't know why, but it stuck with me. So This is a second degree term, so I'm just going to put 2 lines under it. That's 1, constant, constant, 1, 2. Just a visual thing for, hey, these are the terms that will combine with each other. Okay? Yes, I know it gets a little messy. If this was y squared x, like what do you do there? I don't really know. Okay? Anyway, this will turn into 12y squared. Okay? Got it? Okay? Got it. Look at your y's again. Look at your signs. Positive 2. And that's going to turn into minus 2y. Done. Done. Negative 3 minus 2. Got it. Okay? Good to go. Didn't have to do anything else. All right? So there's one method. Let me make a little bit of room here. So there's your horizontal method, right? You're writing everything out horizontally. Here we're going to write everything vertically. Okay? So we're going to take, nope, not an eraser, 7y squared plus 2y minus 3. Okay? And we're going to add to that. And when we do this now, right, we're going to write the term we're going to combine with it underneath it. Okay? So positive 2, positive 2. Negative 4y. Going to combine here. Negative 4y. Positive 5y squared plus 5y squared. Okay? Now go ahead and just add these like we normally would, right? We're just going to go straight down. Again, both of these methods, 12y squared, negative 2y, negative 1. Both of them yield the same trinomial, okay? 2 different ways. Whatever way you're more comfortable with, I'd like you to do, okay? I just stick with horizontal, that's what I've always done, okay? All right, trying to go, we're only halfway there, folks. Either method here, either method, okay? So we're just adding these up. Nothing crazy about this. So these 2 and those 2, right? Hey, maybe you want to circle and circle, right? I don't know, 3 lines here. Who really cares, right? Combine like terms, folks. So this should be negative 3x squared, okay? Combine here, plus 1x minus 2. Good there. You want to try this one, you can. All right, if not, we're going to combine these 2 x's with those 2 x's, this x with that x, and those 2 constants together. Again, adding, best case scenario, because I don't have to do anything. So again, this will turn into negative 2x squared. My x's turn into 5x, right? My constants turn into plus 3. Okay? Adding polynomials, folks, super straightforward. I can't believe we had that many examples on there. I don't really care about B. Let's get right in here to C. Okay? All right, so now we see subtraction. For starters, this is kind of what we need to do here. I need to leave this part alone. And the very first thing I need to do, my friends, is to distribute the negative 1 into all 3 of those terms. Then I can do what I've been doing, which is add or subtract, whatever the signs say to do, okay? So basically, this is going to change the signs of all 3, in this case, terms. If you fail to do this, you'll still combine this term right, because most of our brains say, yep, this is a negative 9. But we will not combine the second term and the third term correctly, okay? All right. So those y's, let's see, those are 2. There's 4, there's 1. There's 4, 1, and 2. Again, do the line thing, don't do the line thing. It's all good. Combine here and here, so that's negative y to the 4th. Combine here and all the way down here, that's going to be plus, I'll say 4y squared. And combine here and here, that's plus 2y. Okay? Again, guys, do me a favor, make sure, right, some of our problems are going to get a little messy here. Make sure you do some kind of way to show me this is your answer, right? Circle it, put a square rectangle around it, highlight it, I don't care. Do something, make it easy on me. Again, subtracting some polynomials here. All right, let's see here. First thing I got to do, change all these signs. So 3x cubed plus 2x squared minus x to the 4th all stays the same. We're going to change these. Distributing that negative sign, looking just like that, okay? So let's combine our x's to the 4th, so negative 1 and 2. That's just going to make 1x to the fourth. Okay, we did that. Again, if you want to cross these out as you go, that's fine. I got a cubed term here. Minus 2x cubed. Done and done. Those are your last two terms, plus x squared. Sweet. Looks good, doesn't it? Okay, done with that one. Again, you want to give this one a shot, you just pause this video, go right ahead. Okay, thankfully we're moving on here. Again, 6n squared plus 11n cubed. Didn't do anything with my trinomial. We will distribute this -1 here and make all of these basically into their opposite term. Okay? Start here. Anybody wants to combine with him? Nope. That's okay. 11n cubed, you just hang out here. Again, sometimes this is where the lines might help you, because you'd be like, oh, this one has not one, but really 3 lines underneath it. None of the others, no other one for it to combine with, okay? All right, here and here. Again, going to be minus n squared. Here and here, minus 2n. Okay, there it is. All right, all done. Again, notice you can add these in whatever order you want. I always choose to find the highest degree term first and then go from there. But you don't have to. Life is all about choices, folks. That's a lot of reading. That's a lot of reading. Okay. Basically, guys, what this says, it says the total amount of toy sales, which they are representing total with T, okay, consists of 2 groups. Okay, so there's 2 groups that we sell toys in. Okay, one is the sales of video games, which they have called V. The other is just regular toys, basically everything else they call R. Okay, in recent years, the sale of traditional toys, R, and the total sales could be represented by the following equations, and here they are. Okay, where n is the number of years since 2010. So the total number of game sales is this weird expression here, right? R represents what? Well, R is traditional toys. And the question here says, write an equation that represents the sales of video games. Okay, so let's go back and think here for a second. Okay, now that we understand the problem, the total sales, right, were equal to video games plus traditional toys, right? That's what it was. But it says write an equation that represents the sales of video games. So I want to make this say, hey, video games equals whatever. So look, can we easily solve this equation for V? Yeah, this is literal equations. This is 3-6 or 3-7, whatever it was. Okay? So solve this equation for V. So in other words, we're going to subtract an R here. Okay? And this will turn into video games equal the total number of sales minus the traditional toys or whatever they were. Okay? Games. I don't know. All right, there it is right there. So video games equals this minus this. You guys good with that? Again, that's all it wanted me to do. Use the equation to predict the video game sales in the year 2022. Okay, so hold on, back up. All right, so I need to write all of this down, don't I? This is very not cool. All right, so we want to take this, okay, 0.45 n cubed minus this 1.85 n squared plus 4.4. Like, who really came up? I mean, honestly, people, who came up with this? Are you kidding me? Okay, so there was my total. So I've done that half. Now we need to go minus, and then we need to put all of this in here. Okay, so 0.46 n cubed minus 1.9 n squared plus 3n plus 19. Okay, and this equals video games. Wowzers. Remember, one last thing. N is the number of years since 2010. Okay? All right, so N was the number of years since 2010. Okay. So for starters, here's what I think we need to do. We probably need to clean up this equation and go ahead and do what we've been doing, right? Which is, hey, distribute the -1 in here to change all of these signs, okay? So watch, like magic, I'm going to do that. This is now going to turn into a minus. This will be a plus, and then these two will become minus. Okay. Now, let's go ahead and gather or collect our like terms. Okay. So again, 1, 2, 3, 2, 1, 2, 3, 2, 1. Okay. So 0.45 minus that. So what is that? Negative 0.01 n cubed. Okay, weird. Here and here. Look, I'm trying to do all this in my brain power, guys. It's late in the day, but I'm feeling good. 0.5 n squared. Okay, this is going to be plus 1.4 n, and plus, let's see, that's going to be what, 3.6. Okay, so again, this equals video game sales. That's what it wants. Use the equation to predict the amount of video game sales in the year 2022. Okay, so guys, last step, right? Is this video pretty long? Oh my gosh, it's 21 minutes. Terrible. Okay, last step. All we have to do, replace n right here, right here, right here. With what number, right? In 2022, should I replace n with 2022? Do a little bit of subtraction, guys. 2022, if you're not sure how many years since 2010 that is, subtract to come up with the number 12, okay? So due to time constraints, right, we are going to just substitute 12 into all that. So you're going to take 12 cubes, multiply it by that. Same thing here, same thing here. I'll do that really quickly, okay, just because you guys are the best. Let's go here. So we want to go 12 as that. Great. Here we go. Negative 0.01. That to the third power. Yes. Plus 0.05. That squared plus 1.4 plus 3.6. Okay. Here's what I get. I got 10.32. Look, if you don't believe me, here it is. I know, it's crazy. It's weird how that worked for me there. Anyway, that's Advanced Graphing Calculator 101. It's a different class you've not enrolled in, so do you not get to know how that works. Anyway, 10.32 is our answer here. Again, this is in millions of dollars. So 10,320,000 were our video game sales that we're predicting in the year 2022. So guys, that's a wrap for 8-1. Hope you had fun. It was great seeing you guys. I'll catch you later.